This is lesson 6 of chapter 8, and in this lesson, we're going to be talking about the surface area of prisms. So, in this chapter so far, we've discussed circles, their circumference, and areas. We also discussed how to find the area of composite figures, okay, and after that, we found the volume of rectangular prisms and triangular prisms, and at the same time, pyramids. So this lesson now we're going to be talking about how to find the area or surface area of prisms. Okay? And this fits well with our question, how do measurements help you describe real world objects? After this lesson, we should be able to answer, for example, if you want to paint your room and you want to find out how much paint you need to use to be able to paint your walls and your ceiling. This is the lesson for that. Okay? And in this lesson, we'll be doing two things, the surface area of a rectangular prism and the surface area of a triangular prism, okay? So we'll skip the real world link and go right away to our lesson. And when we talk about surface area, okay, surface area is simply, okay, when you talk about the word surface and area, you are talking about the sum of all the surfaces of a prism. So here, the surface area of a rectangular prism, okay, with base L, width W, and height H, is the sum of all the areas of its faces. Before we go to the symbols, let's take a look at this clip that I got for you. And if you notice, this is, let's go to a rectangular prism. That's a rectangular prism there. See, there is a rectangular prism. Let's move it around. And if you look at to the right side, that is the net. That's too fast. Okay, that is the net of a rectangular prism, the one in yellow. Okay, look at the one in yellow, and you can see that that is the net of our prism. And if I unpack my rectangular prism, those are my surfaces, okay? So these are my surfaces. What's going to happen now is that we're going to add all those surfaces, the one in yellow, okay? And then that will be the surface area of our rectangular prism, okay? So let's go back to the lesson. Again, it's going to be the sum of the areas of the surfaces. And if you go back here again, let's just go back really quick here, okay? You notice that in a rectangular prism, there are 6 faces. So there are 6 faces here, okay? 1, 2, 3, 4, 5, 6, and that means we are going to add all the faces of those rectangles, and that will make up the surface area, okay? In symbols, it has a formula for finding the surface area of a rectangular prism. So the surface area represented by SA, okay, is equal to 2 times length times width plus 2 times length times height plus 2 times length times width plus 2 times height times width, okay? And this is how the model looks like. So this is your length, width, and the height. Okay, follow that formula and we'll find the surface area of our rectangular prism. Again, the sum of all areas of all the surfaces, the sum of the areas of all surfaces or faces of a 3-dimensional figure is what we call the surface area. So in the inquiry lab where you learned about the nets, I just showed it to you on that clip there. We use the net to find the surface area of a rectangular prism. You can also use a formula to find the surface area, and this is the formula that we will use to find the surface area of our rectangular prism. Then what you need to do when you find the surface area of a 3-dimensional figure, the units are not square units, are square units, not cubic units. Remember, we are going back to area. Okay, an area is always in square units, okay, and it is not in cubic units. Remember that, okay? So let's take a look at example number 1 and let's see how to find the surface area of this rectangular prism. And if you notice here, okay, what you want to do before you even start this is start labeling your rectangular prism, the dimensions of your rectangular prism. I will label this as my length. I can label this as my width, and 13 inches will be my height. Okay, now knowing that, I can first write down the formula for my surface area. Okay, or replacing it first. That's what we did. Replace L with 9, W with 7, H with 13. Okay, and then write down the formula for surface area, which is again 2 times length times height, plus 2 times length times width, plus 2 times height times width. Look at the colors, okay, of those variables so that you know right away what it's referring to. So after that, we substitute our the values. Okay, L is represented by 9. Okay, H is represented by 13. Again, there's your 9. Width is represented by 7. Height is represented by 13. Width is 7. So substituting those values, okay, and we simply do our order of operations. We multiply all three, multiply all three, multiply all three before we start adding them. We get 234 plus 126 plus 182. So the surface area of this rectangular prism is 542. Since again we're talking about area, okay, it's 542 square inches. Or you can write that as 542 inches squared. It's the same thing. Okay? All right, do the got it problems A, B, A, and B. Then let's see if you understand example number 1. Let's take a look at example number 2. Domingo built a toy box 60 inches long, 24 inches wide, and 36 inches high. Has 1/4 of paint that covers about 87 square feet of surface. Does he have enough paint to paint the outside of the toy box? Justify your answer. Okay, let's see what we know first. Okay, so Domingo built a toy box. Okay, these are the dimensions. 60 inches long represents our length. Okay, 24 inches wide represents our width. And 36 inches high represents our height. Okay? What else do we know? We know that he has 1/4 of paint that covers about 87 square feet of surface. So it's asking now, does he have enough paint, enough to paint the outside of the toy box? And let's justify our answer. First, step number 1, find the surface area of the toy box. Okay, that's step number 1. So that means we are replacing L with 60, W with 24, and H with 36. Okay? After we replace those values, we look at our formula for surface area, 2LW plus 2LW. So 2LH plus 2LW plus 2HW. Okay, substitute the values for L, H, and W. We have this. And again, we do our order of operations. We multiply these three, and these three before we add them. So after adding all of them, we end up with 8,928 square inches. Now that's only step number 1 because that's not what it's asking for. So it's asking, does he have enough paint enough to paint the outside of the toy box? Remember that 1/4 of paint covers about 87 square feet of surface. So what do we need to do here is that we need to use that figure, okay, to be able to figure out if he has enough paint or not. So step number 2, find the number of square inches the paint will cover. So we know for a fact that 1 square foot is equal to 1 foot times 1 foot. That's 1 square foot. Okay? So 12 inches by 12 inches is actually the conversion, because 1 foot is equal to 12 inches. So 1 foot by 1 foot is the same as 12 inches by 12 inches. So basically, 1 square foot is actually equal to 144 square inches. Okay? So first, we converted it to inches. Why? Because the toy box is in inches. So now we know that 1 square foot equals 144 square inches. Okay? We can now find if he has enough paint or not. So again, what do we know? We know that 87 square feet, okay, is equal to 87 times 144. Remember, this is the amount of paint. This is the amount of surface area that 1 quart of paint can cover. So all we need to do is get our 87, multiply it by 144, we'll get 12,528 square inches. Okay? Now, if you notice, okay, this is our surface area, which is 8,928 square inches. And this is how much the paint can cover, surface area the paint can cover, 12,528 square inches. So if you compare that, we know that 12,528 is greater than 8,928. So Domingo has enough paint, okay, to cover his toy box. Okay? All right, step number 1. Again, we find the surface area. Then we convert 1 square foot into inches. And we multiply it by 87, which is the amount of square feet, or the amount of surface area 1 quart can cover. And then now we start comparing. Since we know that 1 quart can cover 12,528, and it's greater than the surface area of our toy box, Domingo has enough paint. Okay? Do the got it problem, and let's see if you understand example number 2. Okay? Let's find the area of a triangular prism. So the area of a triangular prism, to find the surface area of a triangular prism, it is more efficient to find the area of each face and calculate the sum of all the faces rather than using a formula. So in a triangular prism, we don't have a set formula, because this is how our triangular prism will look like right there. And if you notice, it has 2 bases, which are both triangles right there, height of 3 inches, okay, and a base of 4. And we have 3 rectangles, okay. Each rectangle has a length of 14 inches right there, okay, and it has a width of 3.6 inches. Okay, so 3 of them. So to be able to find the area of this rectangle, we simply find the areas of these 2 triangles, add the areas of these 3 rectangles, okay, and we find the surface area of our triangular prism. Okay? Let's do example number 3. Okay? See if you understand what I just told you. Marty is mailing his aunt the package shown. How much cardboard is used to create the shipping container? Again, it is a triangular prism. Remember what we need to do. We need to find the area of the 2 bases. That one multiplied by 2. And find the area of the 3 rectangles. Okay? So find the area of each face, and we need to add. So the area of each triangle is 1/2 times 4 times 3. Because the height is 3 inches, the base is 4. Or the answer is 6. So the area of each triangle is 6. Okay? And the area of the 2 rectangles is, remember, area of a rectangle is length times width, is 14 times 3.6. This is the length, that's the width, or 50.4. Okay? So the area got cut off there. the area of the third rectangle is, again, 14 times 4, or 56. Okay? The sum of the areas of the faces will be 6 plus 6 because there are two triangles. These are the two rectangles, and the third rectangle is 56. Remember, it's not an even rectangle, so you need to consider that as well. So after adding all of them, the area is 168.8 square inches. Okay? Let's do the guided problem letter number 3, or sorry, letter D, and let's see if you understand that example. And that's the end of our lesson. Thanks for watching.